Calorimetry problems. Calorimetry is a way that we can use the specific heat formula to figure out what type of metal we have if we have a sample of an unknown metal. In your reading material, there is information about calorimetry, and so if you are trying to figure out the specific heat of a metal or trying to determine which metal you have based on its specific heat, you can use this process called calorimetry. So what you do in calorimetry, you take a hot metal, you add it to cold water in an insulated container that's called a calorimeter. So imagine that you are adding this piece of hot metal into a container of cold water that's well insulated so that you don't lose heat out through the sides, and your water is going to warm up as your metal cools off. Well, however much heat the metal loses will be equal to the amount of heat that the water gains. The water got its extra heat energy now from that metal. So that stands to reason. However much heat energy the metal loses, it's giving that energy to the water. So what we can do, since we know that the amount of heat energy that the metal loses is equal to the heat energy that the water gains, we can then set up our specific heat formula as being equal to each other for the metal and for the water. And what I mean by this is that since Q is amount of heat energy, if I take the mass times change in temperature times specific heat of my metal and how much energy it lost, right, for the amount of heat energy it lost, that will equal out to the mass times change in temperature times specific heat of the water and how much energy it gained. So I take mass times change in temperature times specific heat equals mass times change in temperature times specific heat. So see how I have the mass times change in temperature times specific heat of the metal equals the mass times change in temperature times specific heat of the water. So I will plug in all the information that I know and then solve for the one that I don't know, which in this case for calorimetry is going to be the specific heat of the metal. So in this example, it tells us a 175 gram sample of a metal at 93.5 degrees Celsius was added to 105 grams of water at 23.5 degrees Celsius in a perfectly insulated calorimeter. That means it's not going to lose any heat energy to the environment. The final temperature of the water and metal was 33.8 degrees Celsius. If the specific heat of water is 4.184 joules per degree Celsius, calculate the specific heat of the metal in joules per gram degree Celsius. So we're going to plug in all the numbers that we just got. I know it's a lot of numbers, but let's figure out where they go. Then we're going to solve for what we don't know. So I want to find the heat lost by the metal, and so I'm going to take the mass of the metal, which it gives me here, 175 gram sample of metal, so 175 grams, times the change in temperature of the metal. The metal starts at 93.5 degrees Celsius, and the final temperature of the water and metal is 33.8. So I take 93.5 minus 33.8 to get my change in temperature for the metal. I don't know the specific heat of the metal, that's what I'm trying to find, so I leave this as my unknown. That will equal the heat gained by the water, so I take the mass of the water, which it gives me here, 105 grams of water, times the change in temperature. Again, the water started out at 23.5 degrees Celsius and ended at 33.8 degrees Celsius, so the difference in those two will give me my change in temperature for water, and it tells me that my specific heat of water is 4.184. So to solve for the specific heat of the metal, I want to multiply out the things I already have. 175 times this difference and 105 times this difference times 4.184 and get this answer here. Once I've done those, then I can divide, because right now specific heat is multiplied by these things, and so to get rid of that and have specific heat of the metal all by itself on this side of the equal sign, I need to bring this to the other side and divide, and that's what I've done here. It shows you that this 105 times the difference in temperature times 4.184, when you divide that by this amount, the 175 times the difference in temperature, then you will get your specific heat of the metal. So set it up like this, multiply out both things, keep the specific heat of the metal by itself on one side, bring this over that was next to it, and divide it, and you'll get your answer. So when you set up each of these problems, it's going to ask you to calculate the specific heat of the metal. So first thing I want you to do on each one is to write out that formula every time so that you know you're putting everything in the right spots. So you're going to write out the specific heat formula twice. Put it equal to itself. So the mass of the metal times the change in temperature of the metal times the specific heat of the metal is going to be equal to the mass of the water times the change in temperature of the water times the specific heat of water. And each time for this you're going to use 4.184 as the specific heat of water. Alright, the specific heat of a substance does not change when you're talking about measuring it in the same units. So continue to use 4.184 joules per gram degree Celsius for all the questions on your worksheet. So plug in the things that you know here and solve for the specific heat of the metal by multiplying them out and then dividing this side by what you have here. So do the same thing for all the other problems, and if you do get stuck or have any questions, please do come ask.